Howdy folks. Last time we set up an authorization mechanism for WebSockets to make sure that a poll participant only sends data to the poll they created or joined. As promised, today we'll learn a little bit about exception handling for WebSockets as well as in general. First, however, we're going to enable validation via so-called pipes provided by NestJS. As always, if you'd like to keep up with the code for this tutorial, you can go to my GitHub repo Ranker course and then follow the instructions in getting started. You may want to either clone or dgit a particular branch, and you might also want to check out this tutorial folders, which basically has my scripts for these tutorials. Now, they're not written very nicely. There are a lot of typos, but as you can see, there's a script for each tutorial. Okie dokie, so to get started on creating these validation pipes, I want to first mention that we created in the polls folder this data transfer objects file. That's what DTO stands for. And this had a few classes called create poll and join poll, and then suffixed with DTO. And these classes are decorated, or I should say their fields are decorated with these validators. So for example, a topic must be a string between 1 and 100 characters, and votes per voter should be a number or an integer, to be more specific, between 1 and 5. Unfortunately, I never actually wired up the application to use these sort of decorators, which are provided by the class validator library. What I'd like to do now is open up Postman and then create a request to create a poll and see what happens if we, for example, create a poll with more than 5 votes. Also, to remind you, if we go to the polls controller, you can see there's a method for creating a poll. At the root endpoint, you see there's nothing in this post decorator, and this is expected to have a body with that create poll DTO, or meaning the shape of the class, meaning it has a topic, votes per voter, and name. Here we are. I am going to post to our endpoint with the base URL, which should just be localhost 3000/polls. And the reason it's /polls is our base route of the polls controller is /polls. So let's post this. And of course, we need to start the application first. To start the application, make sure you have Docker or Docker Compose up and running. And then from the root of the project, as always, just run npm start. Let's now try to post with 8 votes per voter. And you can see a poll was successfully created. So this shows that I did not get things working. To fix this, we will use something in NestJS called a pipe. As seen in the NestJS documents here, one use of a pipe is to evaluate input data. So I think I'm referring to this, transforming incoming data, and another use is validation. If we scroll down, we can see one particular use case for this, or one particular built-in sort of pipe, and that is based on the class validator. Maybe if I just search for class validator here, there we go. You would save it and save class transformer. I've already done this. And then it shows an example similar to what we did, where you would create a data transfer object with the class validator decorators. And then it shows that to use this, you will need, well, this is actually something fancier. Let's go and see how do you use it. There are 2 options, really. One is you can register it globally in your app by calling in the bootstrap or main TypeScript file. You can call app.useGlobalPipes, and then you instantiate the validator pipe, which is a built-in class from NestJS. And another way is to decorate a class. Let's see if I can actually find it. I'm just going to search again, use pipes. Here we go. And there's an example here under binding validation pipe. Sorry, it took me jumping around a little to find that. And so then you would instantiate it here. Now, this example actually shows using Joy, or I'm not sure how you say it, validation library instead of the class validator library, but it will be very similar, except that instead of instantiating a JOI validation pipe, we'll instantiate a class validator one, which is actually just called validation pipe. Now, I don't think that they were supporting this pipe when I made this tutorial, or I didn't know how awesome the Joy library is. It's very good for validation, much better than what I use at my job or what we're doing in this tutorial, in my opinion, or at least for more advanced scenarios. Okay, let's put that talk aside now and let's go to our polls controller, and then we will decorate it with a validation pipe. So to do so, we'll just type at WsPipes, and let's import that from NestJS Common. Let's call that and then say new validation pipe. Now, I would register this globally because we'll also end up adding some validation or a DTO for one of our WebSocket messages, but it turns out that instantiating this globally, I do not believe worked with our polls gateway, so I'll just do it on this class, and then later, hey, what the heck? I don't think I did this in my script, but let's add it to the polls gateway as well. Let's save this, and then also add it to the polls gateway. And bring in these imports. And hit command period, not command slash, and save that. Now let's go back to Postman and see if this works properly. Let's now post with 8 votes per voter. And you can see we get a status 400 error, which is a bad request, which is usually used for validation errors. And we get a message in an array saying votes per voter must be greater than 5. Let's see if we do 0. Good, it's saying that it must be less than 1. So it's working there. So that was really about all we had to do insofar as validation pipes go. And so now let's move on to exceptions. In general, we're going to be using a lot of built-in exception handling provided by NestJS. One example is the validation exception thrown by the pipe we added. So for example, if there's an error, this pipe automatically threw that status 400 error, and then it converted that error into the HTTP message that you see here with a status code, message, and error, as well as setting the status code to 400 in the actual HTTP request. Another example is, let's go to our controller authguard here. And you can see that if they do not have a valid JSON web token, we throw a forbidden exception. And this gets in turn converted into an HTTP response with the status of 403, I think, and then adds this message. In our polls repository now, let's see right here, we should have an internal server error somewhere. Let's see, there we go, or an exception, and we throw that, and then that gets converted into an HTTP 500 response. And also, when we're working with the controller or calling downstream methods of the controller, if we just throw a regular old error or exception, let's see, maybe here where we just throw an E, which is any old exception, and that could be an exception that comes from Redis or some other library, it will convert that into an internal server error when we're interacting via HTTP with our server. One obvious thing you may have noticed is that all of these exceptions were converted into HTTP responses. But how do we handle exceptions for WebSockets? Well, first off, it's quite easy to throw exceptions directly with WebSockets. To do so, we can throw something called a WsException, which I'll show you in a minute. In fact, let's make that minute right now by going to our polls gateway. And here, I just want to add a sort of test event to send an error back to the user. Or in other words, I want to add an event handler. So we're not actually just going to send an event, but we're going to receive an event from a client and then immediately throw an error back at them. And actually, we haven't really set up any message subscriptions or handlers, but the way we'll do this in our first case is you create an @subscribe message decorator, and then you give it a title of a message, and in this case, we'll call it test. Later, we'll have things like add poll nomination or leave poll. But for now, this is just a test. We'll call it that. And then you have to give a method, and this probably doesn't need to be async because I'm just going to throw an exception here to see what happens. Let's paste a general exception here, and we'll call it WsException, which I need to import from WebSockets. Now, in this case, I provided a whole object. You could also just provide a string to this WebSocket exception. You can see it takes a string or an object. Now, this message we're subscribing to will not have any payload. Later on, we'll see how we can add the payload into the actual method to access it and then do something with the data. Let's see how we can subscribe or send this message from our Postman client to the server. So the first thing I want to do is actually create a poll that is valid. So let's make maybe 3 votes per voter. And then when we create this, remember that our test section is going to take the responses access token and then save it to an environment variable called token1. That's for player 1. And then if we join a poll with player 2, then they will create a token with the variable token2. So this is just a quick way to kind of mimic having multiple participants in a poll, which will come in handy later on. So let's create the poll. It responds with an access token, and then we will open up our Ranker WebSockets test client 1, which is actually this tab. And you see it's using in a header, it's sending token with value token1, which was just received from that last response. And to send a message, you will type the name of the message in this field here, and then you can put the payload in this part. So for example, if you wanted to send a JSON payload, you would enter it like this. And let's just send an empty JSON payload. I think Postman requires some data. I think it can't be empty. So let's just send an empty object. And I forgot to connect, but I think sometimes when you send the message, it automatically connects to the server. And you can see that we received an exception with that object. And before I get too far, you actually have to set up a listener to listen to exceptions in Postman, which I might not have shown you. And you do that here in events. And then you just type the event you want to receive, and then you would set it up to listen on connect. You can only change this setting when you're disconnected. So let me show you disconnect. You can toggle this. You can delete events. Sometimes I have to go into this tab to delete the listeners, like deleting it here doesn't work. Maybe that's buggy. Maybe that's intended, but just to mention that. So let's connect again and let's send a message. And you can see when we started the server that it says we're listening to exception, and we get that error again. Now, we just threw a WS exception, but what if we just threw a good old-fashioned error? Now, before doing this, I'll mention that all of the exceptions that you'll see inside of NestJS are subclasses or sort of extend the base error from JavaScript. So let's again connect and send a message to test. And you see you get a status of error, message internal server error, which is sort of the default casting from an error exception to the WebSocket exception message by NestJS. So let's work to handle these in a nice way that we like. And maybe the way I'm going to do this is overkill for this tiny little application we're building, but I think it can be useful if you're building something larger. And of course, everyone always says that, but I think I sincerely mean it. Let's now define some standardized exceptions in our application. And to do that, in the source folder, let's create a new thing, new folder called exceptions. It's not just a thing, it is a folder. And the first thing I want to do is create a file called WsExceptions. And we're basically going to extend that base level WsException that we just saw. Now, first, I want to define a TypeScript type, which is a union of some strings. And so this will force us to only throw exceptions with these 3 strings. So we'll have bad request, and I should probably copy and paste this because I'm going to have a typo at some point. I know it, but I'm going to be bold and go for it. And then we have a known. And of course, you have to give your type a name. So we'll call this WsException type. And maybe I should call it like typed WebSocket exception or application WebSocket exception, but you can give it whatever name you want. I don't care. Now, to extend the base WsException, we're going to stick with the class style of NestJS by writing export class WsTypeException. I guess I called this exception type because it's the type, and it's what it limits that our exception must be either bad request, unauthorized, or unknown. Anyway, we'll say extends WsException, and we'll import that. And then in here, we're going to store the type, meaning this bad request or unauthorized or unknown, as a read-only field. Very nice. And then we are going to create a constructor for this exception class. Now save and format all this. And this constructor basically just accepts the type, meaning bad request, unauthorized, or unknown, and some message, or could be an object or any type. I think you could just put this in object to match the types of NestJS a little better, but I think I might have been getting a TypeScript error at some point. I don't now. I'm not a TypeScript expert, but this just basically means it's not known what the type will be at runtime. From that, we will create an error that is actually an object with a type and a message, and we'll pass this to the WebSocket exception. And remember when we threw in WsException last time, it sent a WebSocket message called exception with a payload of an object, or the object that we passed into WsException. So that's what we're doing here. And then we will call the superclass with this object, and then set the type field to whatever is bad request, unauthorized, or unknown. So this is kind of our base exception, and then I want to create 3 specific exceptions from this. And the real reason for doing this is kind of just to make calling or throwing the exceptions easier. So we'll have one called bad request exception, which extends our WS type, and it's basically going to call the superclass with the bad request type and message. For unauthorized, we'll call the superclass with the fixed unauthorized. And for the unknown, I guess you're getting the point now, with unknown. Now, what this union type, which is what you call when you have the little pipe symbol, does is it makes sure that our type is only one of those 3. So if I type blah, this is invalid because it's not a type WS type exception or exception type. Let's now try throwing one of these exceptions inside of our gateway. For now, we'll throw the bad request exception, and then I'll import it. We're going to have to clean up a lot of imports here at some point. And let's see what happens in Postman. So we send that test message again. Let's connect and send. And you see we get type bad request with message invalid or empty data. And since I did that fast, that is the actual string that we included inside of the exception. Now, what we did is pretty cool in general, but sometimes we'll need to convert exceptions. So what we did is great for throwing them, but remember when we threw that error, it didn't send the response as we would like, or maybe you'd like it that way, I don't know, but I don't, to the message of the client. That was a word jumble. Anyhow, to do this in NestJS, we create something called a filter, and you can find this in the overview exception filters section. In general, a lot of the errors in NestJS are HTTP exceptions. And as an example, besides the error that we might want to convert into a WebSocket exception, think of the validation pipe that we just used. If we go to the polls gateway, remember that we use this validation pipe here. Now, if the body of the class validator is invalid, meaning the message that comes in is invalid, it actually throws an HTTP specific exception. So how do we convert that into WebSockets? So that's really what these pipes get at. How you handle this inside of NestJS is with an exception filter, and that's a class that extends exception filter. And you can, inside of a catch decorator, name the actual exception that you want to catch. Now, this could even go up as high as just a plain old error, or this might be the validation exception that I mentioned. What you do then is define this method called catch, And you know in this case that the exception is an HTTP exception because this method only gets called for the exception type in the catch block. And then you get access to the argument host, which has information about HTTP requests, or it will hold the WebSocket client if the received data is coming from WebSockets. We won't go over this too much because we're going to write our own, but let's scroll down and see one other way to do this. And that is to catch everything. So in this case, you'll use the catch decorator, and then you'll still implement the exception filter. Now above it might have extended the exception filter. And I'm wrong, it also implemented it. So exception filter is an interface that has a catch method. Anyhow, back to catching all exceptions, you'd still have this catch method, except that you don't know what the exception coming in is. Now, I might actually define this as an error because all of the exceptions in NestJS should, in theory, extend the error class in JavaScript, so I hope I'm safe in doing that. We'll use this argument host to get access to the WebSocket client so that we can send the exception method or exception message back to the client. And then inside of the method, we'll do a little bit of checking to narrow down the type of the exception, and that will determine how we handle sending messages back to the client. Let's now create a file in exception. It's called what did I call it? Catch-all filter. So in here, we're going to export a class, the WS catch-all filter, which will implement, it's the third time I got this wrong, implements exception filter from NestJS Common, and we're going to decorate this with a catch with no argument inside. Now we need to implement a catch method, and so let's maybe hit Command period and say implement the interface. And the only thing I want to do, which I mentioned, is generalize this to an error type. Then I want to access the socket IO client, and the way we can do that is by saying const socket equals host, and that's that argument host. And you would use this switch to WebSockets. We might have done this earlier, I'm trying to remember, and then get client. And so this will give us access to the underlying socket that basically sent a message to our server. Now, we know that we're using a very specific socket type, and that is that socket with auth that we created in the last tutorial, which basically extends the socket IO socket. Let's add some implementation to this catch method, and I'll copy and paste to make it a little quicker. So first of all, we're going to check if this exception is an instance of the bad request exception, and we'll import that from NestJS Common. And remember, I said that the validation pipe will throw this HTTP exception, but if we're working with WebSockets, we need to convert it. And to get the data of that, we'll call exception get response, which returns the string or object. The exception itself carries some more data, but has this method. And when we're working with exceptions in general in JavaScript, we have this. And then we're going to, from that, create a WebSocket bad request exception, which we defined recently, and we'll import that. And we're either going to take the data from exception data message, or if that's not defined, we'll just send a default of bad request. So hopefully when the exception is thrown, it comes in with a message, which is a standard field of exceptions. But if for some reason it's undefined, we will use bad request. Then we'll take that exception and we'll emit it. And we haven't done this yet, but this is how you send a message back to a socket. And that is with the socket.emit exception. And then we'll say WsException.getError. And getError also returns the string or object that was passed to it. And by it, I mean this WebSocket bad request exception. Otherwise, if it's not a bad request exception, we'll just create an unknown exception. Should be good. And maybe I actually want to get response here. Not 100% sure, and that's probably because the exception at this point is not a bad request exception, it's just an error. All right, so that's the real reason there, is that this is going to be exception message, because at this point, we don't know that our exception is an instance of bad request exception. So let me clarify that. So by default, the exception is of type error from JavaScript, and that has a message on it. All exceptions have a message. Here, we sort of narrow the type by saying that it's an instance of bad request exception, and we know that NestJS exceptions have getResponse. I had to do some playing with this here, but I just recommend you try throwing some error and console.logging these exception fields and methods. It's a little confusing, but I think this works for us. Let's now apply this filter, which is quite easy. We'll go to the polls gateway, and maybe underneath the pipes here, we'll say @useFilters. And then we'll instantiate that catch-all filter we just defined. And we invoke it. So let's now demonstrate this by going to our gateway method at the bottom, this test one, and let's maybe throw a bad request exception. And not a WebSocket bad request exception, but the HTTP bad request exception from NestJS common. And we'll maybe put a method. I guess it's an object or an error. So maybe let's put an object, test, tisk, tisk. Save that baby. Let's see what happens in Postman. So let's connect, send to test again, and we see we get that type bad request, which remember is coming from our WebSocket bad request. So that's what the conversion does, and then it takes that message bad request. But maybe we handled this wrong because I actually want this payload. So let me figure that out, and I'll get right back. But before we figure that out, let's maybe just try throwing an error. An error only can take a string. Bad, really bad. And we'll see what happens with that. There we go. We get type unknown and we get the proper message. So I'll fix that WebSockets one and get right back. Okay, this is the third time I'm filming this part. So let's hope I have a reasonable solution now. So I've updated this just a little bit. We're still going to catch the bad request exception. But what happens is if you go to the polls gateway, for example, and you throw an exception, let's, for example, say it is that bad request exception, and you throw it with an object like this, it will completely overwrite this get response with that object. Whereas normally, if you send a response there, whether an array or a string, it will be captured in the exception data's message field. So you have to be careful with how you do that. And if you want to keep the shape of the bad request exception while passing an object, then you would need to make sure you pass a message field, a status code, I think, and I forget which it's type, but there's a basic interface for these exceptions inside of NestJS. So let's just make this maybe test. Let's go back and make sure we understand the rest of the code. So if there is a message, then I want that to be the message we add to our WebSocket bad request exception. If not, actually take the exception data. So you want to be careful because you might pass a custom object with a message, and in that case, it will use the message. But I think this is going to work fine for any of our use cases. Otherwise, pass the exception's name, which should be bad request, and then we'll admit that. Just remember that right now we're throwing the bad request exception with the test object. If we send that in Postman, now we get the message with test. Let's check with an array. We get the array back. And let's test with a plain old string. All right, so those use cases are working and I'm happy with that. Next time, we're going to go ahead and actually start working with some application logic and the server layer, connecting our WebSocket messages to our actual data source or database, which is Redis, and our service layer, or the pull service, which we created some time ago. Until then, take care. But before you take care, make sure to go and remove all these unused imports in your polls gateway. All right, now you can take care.